Hey all, welcome to this session on GitLab CI/CD. Here I'll walk you through what GitLab CI/CD is and how GitLab CI/CD works using a simple Python project. If you have ever pushed a code and then had to manually test, lint or deploy it, you will know how repetitive, mundane and error-prone that task can get. CI/CD or continuous integration, continuous delivery helps us in automating that entire workflow so that you as a developer can focus on writing code instead of doing all the boring stuff. In this session, we'll start with the basics of CI/CD, then we'll see how GitLab define pipelines using gitlab-ci.yml file, and then finally we'll run a demo to see everything in action. By the end of the session, you'll have an idea of how to set up a pipeline for your own project. So let's get started. So CI/CD or continuous integration and continuous delivery is all about automating a workflow. Continuous integration merges code frequently and runs some checks. Continuous delivery, on the other hand, ensures that code reaches production smoothly. The end goal here is to have better quality and faster releases. GitLab uses gitlab-ci.yml file to define the pipelines. gitlab-ci.yml is a predefined name which is treated as an entry point to the pipeline. Each pipeline that is defined is divided into multiple stages, and each stage are further divided into multiple jobs. Each job here run in an isolated environment, and the execution of the jobs is controlled through rules that lets us control when to run a job. For example, we can run a job only when certain conditions are met. Like for example, a merge request is raised to a particular branch. Here also there are some terms like runner and executor. So runner is an agent that executes your CI/CD jobs in the background, and executor is like an environment in which your jobs run. This environment can be a Docker environment, a shell environment, or a Kubernetes environment. So now let's move on to the next stage, that is the demo. So yeah, this is our final pipeline that we'll be building. Don't be overwhelmed by the size of the pipeline. To make things easier, I have divided the pipeline into multiple parts and we'll be going through each part one by one. Starting off with we'll start with a small pipeline that is which contains a small job, that is the test job, and within the test job there are like a couple of statements that run. These are unique statements. The first statement just prints whatever is given within the quotes, and the second statement prints the current date when the job runs. So this is an example of a normal and a basic pipeline. Now let's go one step further and look at a complex job. So again, this is another pipeline with a single job, that is a build job. Its purpose is here is to create a virtual environment, activate it, and install some dependencies. The dependencies are mentioned within the requirements.txt file, and those are basically this: pytest, pycodestyle, and pylint for now. Here you can see the image key, which tells the GitLab which containers to use. In this case, it's Python 3.9, which is a Docker image with Python 3.9 already installed. So by default, this job is isolated. That is, if there are multiple jobs within the pipeline, this job won't be sharing any data with other jobs. So that is where artifacts come in. So artifacts are files or directories we save from one job so that they can be passed to other later jobs. Here, as you can see, we are saving the environment folder as an artifact so that the later jobs will see it later, but there will be jobs like lint and test jobs which will be reusing this installed dependencies instead of creating and running the environment again and again. So I hope this is clear. Now let's add one more job to our pipeline. So here, as you can see, the build job is the same as before, but we have added one more job, that is a deploy job. So deploy job is to keep things simple. I have kept the deploy job as a placeholder by just mentioning the echo statement. But essentially, it should clone or update the repository into our environment, and that can be prod environment or test environment or any new environment where we are running the actual code. So now our pipeline has two jobs, that is the build job and a deploy job. So now we want to, when multiple jobs come into picture, we want to control the execution of the jobs, and in order to control the execution of the job, stages comes in. So each job, build job or deploy job, uh, is assigned a stage. As you may have already noticed, there is a extra stage tag that is present within the job. So this tag essentially defines which stage this job belongs to. So build job here belongs to the build stage, and the deploy job here belongs to the deploy stage. At the top of the pipeline, you can notice we define stages, and uh, basically within stages we define the order to run the particular stage. So therefore, the order of execution is controlled by the order of stages that is mentioned at the top, and it's not controlled by the order in which the jobs are written. So I hope it's clear what stages are. Now let's move on to the next part. So we have made our pipeline more complex, or more by adding one more stage, that is lint stage. So for lint stage we have added two jobs here, that is lint pylint job and a lint pycode style job. First we'll go through the pylint job. uh, Here you can notice that we are reusing the environment that was passed through our build job by just activating it. Next, we are running pylint on our source folder that is present here, which has main.py file, and the results are getting written into our uh, pylint report.txt file. Then we are formatting it nicely and writing it into markdown into a pylint comment.markdown file. This latest script post post or writes this report into our merge request comment section, so allowing the developers to web linting issues right away in the GitLab. So, and the pycode style job is almost identical to pylint. The difference being it runs pycode style instead of uh, pylint. Now we are done with build stage, lint stage and deploy stage. Let's add one more stage, that is test stage, to basically test our Python code. So here, as you can see, we have added a test stage, and for test stage we have defined one job, that is the test job. Structure wise, you can see that it's almost identical to its predecessors, linter and build jobs. uh, Essentially what we are doing is we are exporting Python path which is required to set the environment variable before running the test. Then we are activating the environment, and finally we are running the pytest on the test folder. So here we have defined a test main file which contains the test functions. So notice here the extra JUnit XML flag. So this flag tells PyTest to output the results in JUnit XML format. Now you might ask why. So JUnit XML format is actually understood by GitLab through artifacts, and through this GitLab will be able to parse the output, and it will automatically show the test output in the test summary tab instead of the comment section, as we saw before for the lint jobs. So with this, our pipeline is almost ready, and but this pipeline will run on every change that is made to the repo, be it any commit message, be it any merge request, or anything. But we don't want that. We want this pipeline to run on a specific triggers. Like for example, here in this case, I want this pipeline to run only when the user has made a merge request into our working branch. That is merge request to our main branch or merge request to our master branch. So here, this is where rules come into picture. So as you can see, there is a rule section. I've added a rule section to almost all of the jobs mentioned in the pipeline. These rules are almost identical to all the jobs. So uh, within rules, I have defined two rules. The first rule tells the runner to run the pipeline only when the user opens a merge request to the master branch. And the second rule says tells the runner to execute this job to only run when the commit is made into a default branch. So these two rules are constant throughout the pipeline except for the deploy job. So unlike other jobs, we don't want a deploy job to run on every merge request that is created. We want our deploy job to be run only when there is a change in our main branch. That is, a merge request is merged, or like changes are made to the main or the master branch. So that is why there is only one rule here, which says run only for changes made to the master or the main branch, and here it will run for two occurrences, run in two occurrences. So I hope it's clear. With this, our pipeline is almost ready, but there are kind of inconsistencies which you might have noticed. So the pipeline now has like 5 jobs that all have identical rules, almost five, that have, and almost all the jobs have the same image configurations. So instead of repeating these rules and image tags, we can use extents and defaults to create a single source of truth. So as you can see here, we have added an image section in a default, created another default section, and added our image tag here, and we have added another job that is preceded by a dot notation. So this dot notation tells the pipeline to treat this entire job as a hidden job. So hidden job don't run explicitly, instead they are developed in a way that are expected to be extended by other jobs. So for example, with our current pipeline, with the help of default, image 3.9 is applied to all the jobs throughout the pipeline, and these rules that are mentioned in the hidden standard rules tab are extended to all the jobs with the help of extends keywords. So essentially we use extend keywords so that jobs like build, test can reuse the standard rules instead of defining them again and again. So here you can also notice that I have not extended it to the deploy job, since deploy job was using a single rule that was different from all the other jobs. So this is our whole pipeline. Now let's try running the pipeline by quickly making a merge request. So let's create a small change. I'll add my full name into the readme so that it will be treated as a change. Now I'll also check which branch I'm currently in. So I am currently in the new branch, which is a kind of feature branch. So I'll quickly add the changes here. Commit, full name, and get push origin new branch. Now as you can see, the changes are pushed. Now here as you can see, the changes are reflected in our GitLab UI. Let's quickly create a merge request through that feature branch. I'll keep everything as default for now since we want to try out our pipeline execution. So just keep everything as default and create a merge request. So here we have created a merge request, and as you can see on the screen, it's running a pipeline here. Let's open a pipeline in a different tab so to get a better view. So as we have defined, merge request will only have will have a build stage, a lint stage, and a test stage. It is missing deploy stage since we have defined deploy stage to be only executed once the changes are done to the master or the main branch. So first it's running build stage, and within build stage we have build job. So let's see the execution of the build job here. Okay, so as you can see, it's using it's also completed. It used a Docker container that with Python 3.9 installed, and finally it installed all the dependencies and it basically exited. So let's go back to this job. Once build job is completed, the runner will go to the lint job. So as you can see, basically the runner is now pointing to the lint stage, and since lint stage had a couple of jobs, both jobs will run parallelly. So you can see the lint jobs are also complete. Now let's wait for the test job to complete. So by the time test is getting completed, let's come back to our merge request section. This was the merge request that we created. So as you can see, PyCode style report is appended by our pipeline into the merge request comment section, and similarly the pylint report is also added to our merge request. So our pipeline execution is also complete. And if you all remember, we had mentioned the special case for our tests. So basically we had written all the tests into our pytest report.xml file. So the reason for that was, instead of writing the test into as a comment, we are adding the tests into GitLab's internal test summary tab, which is this one. So if you click on full report section, it will show you the tests that are executed and errors if any. So for now, my job only the test files only had a single test which tested a single function. So for that, as you can see, there is this test.main which tested this function, test sample function, and the status is passed. So you can also see the details here, and this was our pipeline in action. So this was GitLab CI/CD pipeline in action. So now let's review what we just saw. Coming back to our presentation, so our pipeline had 4 stages, that is build, lint, test and deploy, and each stage here had one or more jobs. So and this pipeline ran only on specific actions, that is the merge request being made to our default branch, or the changes that are changes that were done to our default branch. The build stage here ran a Docker image, pulled the Docker image with Python 3.9 installed, and ran it as a container. It installed it created and installed some dependencies into a virtual environment and saved that virtual environment so that for the successor jobs to basically exploit it. Then came the lint stage, which had 2 jobs, that is lint pylint, which performed code quality checks using pylint, and then there was pycode style job which did the same but with pycode style. So in this for this both jobs, reports were posted as merge request comments in the same UI. Uh, in for the test stage, we saved the report into an XML format to be for that to be understood by GitLab, and because of that we were able to view the report in the nice UI that was provided by GitLab itself. Deploy stage here was a kind of placeholder for deployment, but essentially that job or that stage should be responsible for replicating the changes into our environment, and that environment can be Amazon EC2 or Azure containers or even Google containers, anything. Also, we saw the execution, how we can control the execution of the pipelines. For examples, through rules. So here we define standard rules, that is which controlled the jobs to be executed only on merge request or changes that were made to the default branch. And we again saw that the deploy stage ran. We made ensure that deploy stage ran only when the changes were made to the default branch. So through this we have basically avoided and prevented unnecessary job runs. So finally, concluding the session, essentially this pipeline gives developer quick feedback, enforces code quality, and ensures that tests run in a consistent environment. And the pipeline was really easy to be extended into the real deployment. So basically, what we can say through this is uh, CI/CD automates our code workflow. Our demo pipeline and our demo pipeline was also able to cover build, lint, test, and deploy jobs. So this is a kind of solid foundation for real projects, and you can also expand it for future deployment later. And I hope you guys were able to learn a lot about CI/CD. Again, if you guys have any questions, feel free to drop them in the comment section. Thank you.